talked about starting to do some software development, fantastic. We've talked about the challenges that you run into while you're doing software development. And then last time, we started to have a discussion about all the things that you have to do when you reach the end of an iteration. You have a party, I think we established that, so that's good stuff. But it turns out there's a bunch of other stuff they have to do, including things like, oh, I don't know, system testing. Because remember, when you hit the end of an iteration, for the very, very, very first time, suddenly you have a complete chunk of code. Look, especially if it's the first iteration, it probably doesn't do everything it's supposed to do. We're cool with that. But if you're done with an iteration, it certainly does something. And if it's doing something, then what you want to do is take some time at that point in time and do some system testing and actually go ahead and test it, just because it makes life good. All right? So let's wrap up our discussion about what you do at the end of an iteration here. All right. So we talked a little bit about system testing. Let's talk about what goes into effective system testing. So first off, good frequent communication. So remember, when you're doing system testing, and it always comes down to the size of the organization that you're involved in. If it's a small organization, everybody's doing system testing because there are no other bodies to do it, right? But assuming that you're at a medium or even larger sized organization, there's probably a dedicated set of people who do nothing but system testing. Fantastic. You've produced some code, you hand it off to them, and poof, they're off and running, testing it and stuff like that. Now this is the time when you want to make sure that the developers, the people who wrote the code, and the people who are testing it actually have good communication. It's very, very easy for them not to talk to each other, right? The people testing it can create bug reports and just move on. The developers, of course, have moved on to the next iteration of doing code, right? The last one is just gone, it's out of their mind. But if you force them to actually talk, and if you force them to actually work together, it's going to make life smoother for everybody involved. When you're doing system testing, you need to know the starting and ending states of the system, and that's really critical, because if I'm going to take a system and I'm going to have an order entered, and then I'm going to go ahead and pay for it with my Visa, and then I'm going to go ahead and book my room, and I'm going to pick the food I want to have, it always has to start in the same state. Okay? If I'm halfway through another order, or if there's 3,000 people using the system, or other weird stuff going on, I'm going to be challenged to get the same results out of the system every time I run my test, right? So you have to be very, very careful about what state the system is when it starts, and you have to be very aware of what the state of the system is when you end. You really want to end up with the same thing. Documenting your test has got to be one of the most boring things in the world. It's also one of the most critical things. So we've talked a little bit about this, but when you create a test case, you are effectively writing code. When we think about code, it's in the class in Python. We know what code is, right? Well, it turns out that if you're writing a test case, set this to this, set this to this, do these steps, whether you're programming a test case, writing it in some sort of test scripting language, or whether you're just writing it on a piece of paper that you hand to somebody who then follows those instructions, either way, it doesn't much matter, you're effectively coding up a test case. And whenever you do something like that, you're going to have to document what the heck the test is. So this test is designed to test this bit of functionality, and these are the results that I'm expecting to get. If you just create test case number 14 and hand it off to somebody, who the heck knows what the heck that is, right? What's going to happen is you are going to forget what you've already tested, they're going to forget what they're testing, they'll run through all your test cases, and at the end we say, look, when we passed the tests, all the tests passed, we go, great, how much coverage do we have? How much of this piece of software we actually tested? And absolutely nobody's going to have anything to do with it. So documentation when you're doing test cases is critical. Establish a clear success criteria. The perfect success criteria is I tested all your code and it works perfectly. And I love perfect things, but we unfortunately don't live in that particular world. Right? We've talked a little bit about this, but when you're creating test cases for software, you're probably not going to have the time or the energy to test all of your software. I mean, that'd be perfect. I like to take every path. I'd like to try every value. I like to try every weird condition I possibly can think up and stuff like that. Great, that's wonderful, that's fantastic. You ain't got enough time to pull that off. All right? So you got to set a very clear objective for yourself. How much are you actually going to test? Once again, the rule of thumb in the industry is somewhere between 85 to 95% of your testing. Okay? You're going to leave some of the code untested, okay? But that's okay. If you pick it correctly, the untested stuff is not that important. Okay? It's the least important part of your code. Okay? But you need to make sure that you're very, very clear on exactly when you can say, I'm done testing. Oh, hey, look, good frequent communication. If it's in the list again, that means it's actually really, really important. You want to automate your testing wherever possible. We've been talking about these test cases. We've been talking about trying to make your test cases as small as possible, right? I want to create a test to test one little tiny bit of functionality. Well, that sounds great, and it actually is a great thing to do. The challenge of what's going to happen is you're going to end up with a lot of test cases. Okay, so that's good. That's fantastic. A lot of test cases test a lot of functionality. Relatively easy to maintain because each test case just tests one particular function. So if you make a change to that function, you only have one or two test cases you have to change. These are all great things. The problem with having lots and lots and lots of test cases is when it comes time to actually run them. Oh my God. So I've got 500 test cases. I'm going to have to sit there and run one, run two, run three, no way. Okay? What you want to do is you want to automate it. You want to automate the running of all of them as much as you possibly can. So you can have one button and it runs all 500 of your test cases, and then it comes back and gives you a report. Hey, look, most of them ran, but 5 of them had problems. Go check it out. Okay? You want to create a cooperative dynamic between testing and development teams. We've already sort of talked about that. While the testing teams are doing stuff, they're going to run into things they don't understand. You're going to encounter things where the system's behaving in a way that seems strange or unusual to them. Okay, not a problem. Maybe the system's supposed to do that. We don't have any problems with that whatsoever. They just need to have a clear way to be able to talk to the development team and ask them questions. Okay? Number 8 is create a good view of the big picture by the testing team. I'm testing an order entry system so people can make a reservation in my shack that's on a pond for people to come. Make sure the testing team understands the big picture. You can get lost in the world of making payments via Visa, MasterCard, other systems and stuff like that. That's great, that's wonderful, but really you want to keep the big picture in mind so when they're developing their tests, they make sure that the functionality that they're currently working on fits with the overall thing. If it doesn't, then they've got a problem and they need to report that. Accurate system documentation. If I'm developing test cases for each system, I need to know what your system's like. How much memory does it take? What kind of processor does it run on? What version of the operating system did you design it to work on? Because I'm going to use all that information to create my test cases. If I don't have accurate information, then I can go ahead and test it on an old version of Windows. I can test it using the wrong type of database, etc., etc., etc. And what that means is that all my testing was for naught, because the testing that I did doesn't look anything like the real-world environment in which the customers are going to end up using this particular piece of software. So they may run into 1,000 problems that I never saw in testing because my system didn't look like theirs. And item number 10, of course, is good and frequent communication, trying to drive a point home that having your testing team talk with your development team is the core of what's going to make for good system testing. Any questions here? Talk, talk, talk. That's what it's all about. All right. How to deal with bugs. All right. So, we talk about testing. We sort of gloss over the fact that what testing is designed to do is to find errors in your code. And as you know from your homework, you carefully read the problem, you carefully type up your program, you hit run, and immediately the red lines of death show up, indicating, I got an error, I'm going to fix it. You run it again, and there's more errors, and more errors, and more errors. Well, that's exactly what happens when you have a testing team do stuff. So you're going to have a tester running some code, and he's going to find something that's wrong. And when he finds something that's wrong, it's not necessarily going to be like the screen goes blue, and the system goes belly up. It could be a failure like that, but it also could be poor documentation. It could be that the documentation that he has about how the system's supposed to work says that it should be producing a green bar, and he sees a yellow bar, okay? Or something as simple as that. Or even worse, if you go looking for option number 3 on the menu, and it turns out there is no option number 3. For whatever reason, you forgot to implement it. But no matter what the problem is, he finds a bug. He finds something that's not operating the way it should. So what does the tester do? Well, he documents it. Okay? So as a tester, what you do is you fill out what we call a bug report. Bug reports are used to track bugs. Remember, if I have more than one person testing the system, that means I'm going to have more than one person finding things that are wrong with the system on any given day. I need a way to keep track of all the issues that they're finding, and that's exactly what tracking bugs is all about. The level of detail that they provide when they create a bug report is absolutely critical. So if you have a big and complex system that has a lot of moving parts, when you turn in a bug report, you have to be real specific about where you were, what you were trying to do, and why you think it's a bug, right? Once again, testers make mistakes. That's exactly what the system was supposed to do. I'm not sure why you were putting that as a bug, right? Okay? You have to say what you were trying to do. You're trying to have to say, did the system give any error messages? Can't find, don't know what you're trying to say, that's not a valid option. What did the system tell you when you're trying to do it? What I'm going to try and do then, when you file a bug report, is I'm going to try and go back and recreate the steps from the developer so I can get to the point where the bug happens, so I can inspect my code, put in some print statements or what have you, and find out what's going on at that point in time. So I need to make sure that you put in the steps that are required to recreate what caused that bug to happen. And finally, if you're saying that that bug happened, it's because you were trying to do something, trying to achieve some sort of outcome, and you weren't able to do it. That's fine. Good question. What were you expecting to have happen? Okay? Maybe whatever you were expecting to have happen is completely unreasonable. Maybe it's not something that this particular system does. If that's true, then you need to document it, and when I read your bug report, we're going to have a talk about that. Finally, you need to create a story or a task to fix the bug. Assuming that you agree that the bug is a real bug, then what you're going to have to do is get the bug fixed. Okay, not a big deal whatsoever. If you're going to get the bug fixed, the way you're going to do that is you're going to create a user story based on that particular bug, and then you're going to work it into your next iteration. It will become a user story that needs to be solved by the developer. Makes perfect sense, right? Add tasks as needed. So, here's the thing that doesn't work. You're not necessarily going to have to change one thing. You might actually have to change 3 or 4 things. Change something in the database, change something in the code, change something in the user interface. I'm not sure. But maybe you have to break that bug fix up into multiple tasks. And it is always a bit of a challenge. A bug as a report is something that doesn't work correctly. You have absolutely no idea how much effort it's going to take to fix that. Oftentimes a big chunk of fixing, a big chunk of the time required to fix a bug is to find the code that's not working correctly. So I understand it's not doing something right, but I don't know why. So I'm going to have to go do some investigation. And that can take a lot of time. So it makes basically bug fixes are notoriously hard to estimate. Okay, so we fixed the bug. Yay, fantastic. So we'll make it part of an iteration. That's when we're actually going to spend the time identifying what code isn't working correctly, coming up with a fix, implementing a fix, and of course doing unit testing to make sure that whatever change we make to the code actually fixed the bug. If we're doing things using test-driven development, we will of course create the test first, right? So if the code was working correctly, then this is what it should be doing. Now remember, when we create that test, we run it against the code, it should fail right off the bat, because that's our rule. Okay, and then we'll change the code to make it work. Now, in our fantastic, wonderful bug tracking piece of software, when we fix the bug, we will mark the bug as being fixed. Right? It was in a state, generally the state that it was in was open. In other words, we know it's there, it's been assigned, and people are working on it. We will then move it from open to fixed. Now notice that fixed is not the same as tested, closed, or verified. It's just the start of the process. It says, as a developer, I believe that I've created code that now fixes this problem, and you're communicating to the rest of the organization. What will happen is it'll go back to the testers, the people who found it originally, and they will actually go back and they will test your change. Now, of course, fingers crossed, toes crossed, all that sort of stuff like that. Hopefully, when they get around to testing the change that you implemented, they will agree with you and say, yes, congratulations, the changes that you made to your code did fix this problem. I consider this bug to be no more. Now, what the tester is going to do is they're going to go into the bug tracking system that you have, and they'll actually change the bug status to close. All right, so we're getting closer to getting this one out the door. But you can see that we're starting to communicate to people using the bug tracker system. Then finally, when you're actually doing a release, you're going to want to update the bug report. But what you'll do now is you'll actually go ahead and you'll close the bug report. I have a release of the software that contains the fix for this bug, and that release of software has actually been released to the world. I will now go ahead and close the bug report because I'm all done with it, okay? I can use the report as a script for retest. When people are doing their system level testing with this brand new piece of software, they can go in and see which bugs I'm claiming got fixed in it, and they can double check to make sure that that got taken care of. And I'm not going to actually delete the bug because there's always a possibility I have to come back and go, gosh, didn't we fix that problem like 3 releases ago? Because bugs do have a nasty habit of occasionally popping back up. You don't like it when it happens? Okay. But why create a bug report? Sounds like a pain in the butt. It sounds like it's a lot of like writing. It is actually. So a bug is an issue that you have to address. You can't sweep it under the carpet. You can't pretend like it's not there. Something's actually wrong with your software, and you're going to have to do something about it. Bugs do have to be recorded and tracked, because if you don't do that, they're never going to go away. There's a lot of different bug tracking programs out there. One really popular one that I'm sure that you'll encounter sooner rather than later is a program called Bugzilla. A lot of shops use that. It's free, it's open source, and it's actually a really, really good program. You can use your bug tracker to do the following. You can record and communicate bug priorities. You can keep track of everything, and you can generate metrics. So basically, you are sitting on top of a big pile of data, and that pile of data is telling you what the status is of all the bug reports that are coming on your code. Your goal always is to get the list of open bugs down to as small a number as you possibly can. The company that I work for right now, I think we've got a bug list of about 160. We try to keep it at about 100 or so, roughly, open issues at any point in time. We try to make sure that none of those open issues get to be too old. We find that the number one thing that takes us the longest time to close a bug isn't so much us, but rather it's the communication with the customer. So the customer opens up a bug, we may have to reach back out to the customer to get more information on it. What were you doing? Why were you doing? What were you expecting? Customers can go on vacation or they make this with other stuff, and then just a little sweet time getting back to you. That definitely delays us when it comes time to actually try to close bugs. Okay. So what actually goes into one of these bug report things? Okay. More information is always better information. There's no question about that whatsoever. Basically, there's 5 high-level sections to every bug report. First thing is the summary. What were you trying to do and what did you see? I mean, you're going through the effort of creating a bug report. So clearly you think that something's not working correctly. So tell me, why are you opening up this bug report in the first place? Number 2, tell me what you were doing when this problem showed up. And what you're really trying to do is you're trying to document the steps that you went through. So if you handed the bug report to somebody else, which you will be doing, a software developer who gets assigned to fix this problem, here's what you have to do to make this problem show up. Okay? Once again, number 3 is talking about, so what did you think was going to happen? You'd be surprised more often than not, what they expected to happen never happened in the system. They, for some odd and strange reason, they got it in their mind that it was going to do something it just does not do. Number 4 is actually really, really critical. It's version, platform, and location information. So what were you running this on? Were you running it on your laptop? What version of Windows or of Mac OS were you using? What version of the database were you using? What version of the network software were you using? Were you using a browser? Which one? Was it Safari or Firefox or Chrome or Explorer? More importantly, which version of the browser were you using? They all have different behavior characteristics. And if you're seeing weird stuff happen on your screen, it could be more of a browser issue than actually a software issue. So explain to me exactly what you're using when you saw this. And then, of course, the last one is severity and priority. At the company that I work at, we've classified them into basically 3 levels. Okay? The most severe problems are when the customer can't do something. I want to pay for an order. Well, if something's wrong with the code, you can't pay for an order, because that's a critical issue, right? Number 2 is sort of, I can't do something, but there is a workaround. I mean, I can't use your primary payment method, but there is another way for me to actually end up doing it. Okay, it's an inconvenience, but we can live with that. And the 3rd level priority is the lowest. It's something I can't do, but I don't really care. It's just sort of a nice to have. It's not something that's actually critical to me. And once again, you can see how much time you put into it is based on that priority level. Okay, so what else can we do? We talked about this last time. Remember, we talked about process improvements, making things better. System testing is what we're talking about right now. There was the refactoring of code, which is the fancy way of saying go back to working code and see if you can make the working code better. If you can redo it in a way that takes up less code or does it in a more effective way. Code cleanup and documentation, development environment updates, R&D on new types of technology to work in, and then of course, personal development for you. You taking classes or studying the things that make you a better worker. Okay. Software development process. Software development process is all about prioritization. There's no shortage of things that you could possibly do when you're working on a software project. Okay? There's a lot of stuff to be done. the big question and the question that you need to be able to answer is, what should you be doing now? And once you know now, what should you be doing next? You have to make sure that you're doing the right thing on the project at all times. You know, there's a lot of different things you can do that would be a waste of your time if you're not careful. So you got to make sure that you're focused, because arguably every day has a limited amount of time. We've talked about how long an iteration is. We're saying it's about 20 days long. You know, if you smoke a day or two, all of a sudden you just chopped off, 10 or 20% of how much time you have to use for software development. Your goal is to produce working code. Number one goal is to produce working code. Number two goal is to produce high quality code. Yeah, you produce a working code that's not all that high quality, I can live with that because it works, right? It does what it has to do. I really would prefer to have high quality working code, but I can live with working code, okay? And you always want to be improving your process. Whatever system you've put in place to develop software, hopefully it produces software, so congratulations, that's fantastic. But that doesn't mean that you should stop there. You always need to be going back and you need to be taking a look at how you're doing things, and looking for better ways to go about doing it. All right, software development is not just about code. We know that because it has to do with testing, it has to do with communication, it has to do with making sure that you create all the right things you have to create. It's about good habits and approaches to delivering the working software. And of course, as you know from your midterm exam, software development is all about producing code that is both on time and on budget. Now, how do we prioritize the additional nights to have tasks? Remember, this comes down to if you have a couple of days left over at the end of your iteration. It depends on where we are in the project. So in other words, if this is iteration number 1 or number 2, we're early on in a project, we haven't had a chance to do a lot of stuff. If we have any time left over, we'll probably spend our time doing some refactoring to make sure we've got the best design possible. If we're farther into the project, maybe this is iteration 4, 5, or 6, or something like that. If we have any time left over, we'll probably spend our time working on documentation or even technology alternatives. Hey, we've done a great job using this particular database, but I heard about this other type of database that's supposed to be quicker, better, faster, and it's like the hottest thing since sliced bread. How about if we go ahead and take a look to see what would happen if we switched over and used that other database? Okay, great question, but you have to have the time to be able to do that. And that's the kind of thing you would do later in the project rather than early. Iteration review. So you're done with an iteration. Okay, you have the big party, you come back into the office the next day, and it's time to do a review. Basically what this is a sit-down meeting where you talk about how things went. Sort of like if you went on a date, and then like the next day you got the other person and you said, hey, so what did you think of that date? And you sort of had a little check-off list. Well, you picked me up late, that one's so good. Restaurant, you could have probably done better on that. Movie, who picked that movie? That bitch is it. Whatever. So it's the same sort of thing, right? It's basically going over what you did while you were developing the software and saying, listen, congratulations, you did it. So let's take 2 thumbs up for that one. But the question is what could we have done better? Okay? You got to do it with the team. Obviously, elements of an iteration review, you need to prepare for it. You can't just walk in and sort of whip it off the top of your head. You need to be forward-looking, saying, listen, the next time that we do this, an interesting thing on that one is you can also take a look at what time of year you get ready to do things. Hey, look, it's November. We just completed an iteration. This is great. The next iteration we're going to do is in the month of December. What happens in December? Christmas. So what would you expect most of your team to do? They would take off, right? Are you going to have 20 days to do software development in December? No. Probably have like 14 days max, right? Yes. Oh, actually, I'm sorry, 10 days probably. Calculate your metrics. Remember, we've got that velocity thing that shows how effective our team is. Well, if we're done with an iteration, that means we've got some new numbers. So we can recalculate our velocity. And we can find out, hey, wow, this team's a lot more productive than I was expecting them to be. Or, oh, you're not nearly as productive as I thought you were going to be. Maybe we need to take a little step back now. Generally having a standard set of questions to review during any sort of iteration review is a critical thing to do there. Look, you're not making this up on the fly. There's a series of things you have to ask, what did you think, how did it go, all that sort of stuff like that. Questions could look something like this. Is everybody happy with the quality of the work, with the documentation, with the testing? You need to get feedback from the team. How did everybody feel about the pace of the iteration? Was it going way too fast, or was it like, oh man, I was done with all my stuff, like 3 days in, and I just sort of sat around and played Pong for the rest of the time. Is everybody comfortable with the part of the system that they were working on? I'm a user interface person, and I don't know the first thing about user interfaces, so no, I'm not comfortable with that. Are there any tools that are helping or hurting productivity? The hurting is an interesting concept, right? We've adopted this tool to use on this particular project. That tool sucks. It takes a long time to understand, takes a long time to boot up, and I don't think it works very well to begin with. You'll give the feedback now. Was the process effective? Did we get it done on time? Or did it sort of hinder what was going on? Is there any code that should be rewritten? Yeah, his code. His code sucks, man. We should know. Okay, that's not really what we're saying here. But there might be some code that your code relies on that runs slow, or it's got a bad interface or stuff like that. Point it out at this particular point in time. Performance problems, screens are slow to load, or any of that sort of stuff like that. Bugs identified that have to be talked about before prioritization, testing effective, is the deployment process repeatable. Oh my God. Okay, so I mean that's just a starter set of things you could talk about when you're talking about how the iteration went. Okay? Once again, this is a good idea because then what happens is that you can prepare for the next iteration. You can say, these are the things that worked well last time, yay, let's do them again. And oh, by the way, these are the things that were not so good about the last iteration, so maybe we should not do them again. Seems to make sense. All right, cool. General list of getting things done. Number 1, fix bugs. All right, that makes sense, okay? Number 2, pull in the stories for the next iteration. What are we actually going to work on next time? Prototype some solutions for the next iteration. If you're doing some sort of big, scary code, have a team talk and say, how are we going to do that big, scary code? What's the best design approach to getting that taken care of? And make sure you've got training and learning time so that everybody has a chance to make sure that they have the right skill sets so they're going to be able to develop the best code next time around. Oof. All right, so what did we cover today? We talked more about system testing and the fact that system testing is a critical part of the software development process. Remember, when you finally have the whole system, that's your chance to make sure that the thing does exactly what your end users are expecting. We talked about dealing with bugs. A big part of bugs is making sure that you do a good job of documenting them, right? When they show up, the person who finds them has to write down what they were doing, why they were doing, and what they were expecting to have happen when those bugs showed up, okay? And then we talked about iteration review. The only way you're ever going to get better at doing this stuff is if you take the time to sit down and say, hey, how did it go last time, and what can we do better next time? Gotcha. All right, that's what we covered today. What are we going to cover next time? Oh my gosh, this iteration stuff just does not end. We're going to talk about the next iteration next time. Sounds like a good deal. But right now, we'll probably talk a little bit about from Python. Oh my goodness, there's more to that function stuff. We take a break for about 15 minutes. I'll see you back here at 9 o'clock.